Hi, and welcome back to Clean Code and Programming Principles, the Ultimate Beginner's Guide. My name is Spiros, this is the Programming Duck channel, and in this video we're going to talk about side effects. So why are we talking about side effects? It's because side effects are essential for all programs. If a program doesn't have side effects, it means that it doesn't do anything useful. It just does some calculations off on its own, but those results are never displayed to the world or written anywhere or anything like that. So for a program to be useful, it needs side effects. It needs to do those things like display the results, write the results somewhere, all those things. So we need them. But the problem with them is that side effects can be a major source of bugs in all code bases. They're very tricky to work with and very difficult to handle. And because they're essential and because they're so tricky, you must know how to handle them effectively. So this is what this video will show you how to do. So what are side effects? And there are a few ways to describe them. But primarily the definition that we have in programming is that a side effect is anything whatsoever that changes the state of the system. So this basically means any mutation at all that occurs in the system. Things like changing the value of a variable, logging to the console, modifying the DOM, modifying the database, or anything else you can think of. And another thing about them that may not immediately appear to be a side effect is also something like an action. Something like sending data over the network, for example. And finally, at least with my personal definition, I also consider everything that accesses non-local scope on something mutable to also be a side effect. For example, if your functions or methods access some global variable or something outside of their local scope that can be mutated, I also consider that to be a side effect. And that doesn't technically fall under the programming definition of side effect, but I group that together because it's just as unsafe as all other side effects. And this, in fact, this accessing of globals and things is where side effects start to become tricky and difficult to work with. So that's why I group it together. So to summarize, a side effect is a mutation or an action, or with my definition at least, something that accesses non-local scope on something mutable. Now, the problem with side effects, unfortunately, is that they can be pretty dangerous and pretty tricky to work with. And let me tell you right up front that that's not because side effects are inherently bad. Side effects are actually essential code, as we said. If a program doesn't have side effects, then it's useless. And having a side effect in your code doesn't mean that the code is bad or that the code will definitely have bugs. That's not the issue. The issue is that side effects tend to work with globals a lot of the time, things like the database or the document object model, the DOM for front-end developers. And that's fine, but the problem is that they're globals. And globals means that anything in the code base has access to them. Anything can change them, anything can depend on them. And if you think back to the principle of least knowledge, a situation like that is just impossible to deal with. Because we, the programmers, we don't have the kind of memory capacity and awareness to be able to know everything that might change, say, the DOM and what could possibly break. 1,000 things could break and 1,000 things can change the DOM. So it just becomes an impossible situation unless we deal with it very diligently and we have a lot of discipline in how we write our side effects. And then on top of that, we have asynchronicity, where code doesn't happen one after the other. We have user events and things like that. So things happen at different times. And that makes it even more difficult to reason about your code and to think, okay, what's going to break when this runs, and things like that. So that's the issue here. And on top of that, code with side effects also tends to be more difficult to test. So it's just problem after problem compounded. So to summarize, side effects are not bad. They're just dangerous if not handled and coded properly. So how do we handle side effects? Thankfully, there are quite a few ways to do it, and they're basically all applications of the principles that we've looked at so far in this series. So if you apply those principles perfectly, you should be pretty good with your side effects. However, for some more detailed pointers, consider something like this. So, as always, be pragmatic, use immutability, avoid non-local scope, be extremely careful with side effects when you do need them, because the previous points are about avoiding side effects. Separate pure and impure functionality, have clear areas of responsibility in your code, handle side effects that come in pairs properly and effectively, and finally consider using a framework or a functional programming language to delegate some of those side effects too. So that's quite a lot of points, so let's look at each one in detail. The first point is to be pragmatic, and this is a point that we've encountered in every principle so far. And what this says is that remember that you don't need to get rid of all side effects in your code, because side effects aren't necessarily bad. All you need to do is make sure that your code doesn't have bugs. So for example, we have two functions on this slide, sumRange1 and sumRange2. And the function on the left doesn't use immutability, but the function on the right uses immutability. And please, for the sake of this example, ignore the technical limitations of recursion and that the function isn't tail call optimized. Just pretend it is and pretend we're not using JavaScript, we're using a language that actually tail call optimizes properly. So ignore that. Focus on the side effects aspect and the clean code aspect here. Okay, so one of these functions uses immutability, and that's generally good. However, think about it. In these particular functions, it doesn't matter whether they use immutability or not, because both of them are exactly the same code from any caller's point of view. And if you run either of these functions, no other code could possibly break in the entire code base. So yes, the function on the left has side effects because it modifies the values of the variables in there, but it doesn't matter. So if you're being pragmatic and your team isn't comfortable with recursion, don't be afraid to just use the left one. If you understand what you're doing and you use your professional judgment properly, it doesn't matter which one you use. You know what's best for your code base. So always do that. Don't go crazy with applying these principles. Having said that, immutability is the best way to avoid all possible side effects that are not necessary in your code. So if a side effect isn't necessary, just by applying immutability, you won't have it. So this is great because this means you get to handle side effects by removing side effects. This is a really good thing to do. And immutability helps because if something is immutable, it means its value doesn't change, and it means it's not a side effect. And why does that matter? Well, side effect or not doesn't matter. What applies here instead is the principle of least knowledge that we looked at a few videos ago. If something doesn't change, the code is basically safe. It means that you don't have to worry about, okay, this thing changed and now 10 other things are broken. And you don't have to remember, okay, this thing is here and 10 things depend on it, I'd better not change it. It's the principle of least knowledge in action. And this helps directly with side effects. If something doesn't change, you don't have to worry about breaking everything. So yeah, immutability is a great way to avoid all unnecessary side effects in your code. And how do you apply immutability? Thankfully, it's fairly simple. So basically, if you have a variable in your code and it's assigned to a primitive value, let's just say it's assigned to a number. So if you need to do an operation with that number, don't overwrite the variable. So if you have a variable named foo assigned to 5, don't change it to 10. Instead, create a new variable and then assign that to 10. So that way your original variable foo is left unmodified. And that's what you want. It means that anything that depends on foo won't break now. And if your variable is mutable, so for example, if you have a variable, again, called foo that holds an array, and say you need to add another element to the end of that array, so how you do that is you don't modify the original array. Yet again, you create a new variable and you copy the old array onto that new variable. So now you have two of the same arrays. And now you do your change, you add the element to your new array. So now your new array has the answer that you want, and your old array is unmodified. That's how you apply immutability to your code. And here is a quick code example of what you want to do and what you don't want to do to apply immutability. So the code on the left takes in an array and it modifies the array in place. The function is called double array. It doubles every element of the array. But this code on the left modifies the array in place. And that's not what you want to do. What you want to do instead is have code like the function on the right. which takes in an array and returns a new array with the correct results. And we went over this in the principle of least knowledge, so I won't spend too long talking about it. But basically, working with something on the left could be a disaster for your code, especially if your code base is quite large. And working with something on the right will always be predictable. You always know what the code is going to do, and you never have to worry about anything breaking when you modify objects in place. And finally, you may be worried that by using mutability like this everywhere, the performance of your application may suffer. But for the most part, you don't have to worry about that. For starters, you don't want to do premature optimization for performance on your code. You should only do performance optimization if it's actually necessary, because anything else is basically a waste of time and it won't actually help your application. And using immutability like this in most cases won't really affect the performance of your application, at least not in a noticeable way. Because if you're only modifying arrays like this once in a blue moon, then it probably won't actually matter to your user. But if performance is affected, you also have the option of using something like a performant immutable data structures library, like for example something like impure for the JavaScript programming language. That's a library that basically has data structures under the hood for things like objects and arrays and stuff like that, so that something like, for example, copying an entire array, which would normally take big O of n time, now becomes big O of 1 time. So that's constant time. Now, it's not all benefits. There are some trade-offs when you do something like this. So for example, if it changes the time that some operation take, it's because it's using a different data structure underneath. So it also changes the time of some other operations. So again, it's not all benefits, but this might be the kind of thing that you need to use immutable data structures in your code base. And the last point about this is to remember to be pragmatic. You don't need to use immutability on everything. But of course, the more things you use it on, the better your code will be. But as we examined, for example, if you have a function, say the function map, every time you add an element to the result array in your map function, you don't need to create a brand new array, because that's just a waste of resources and of performance. You can have just one array that's mutable for your entire duration of your map function, and then just return that one array. And as far as the entire rest of the program is concerned, that is still a pure function. The next big point in avoiding side effects is to avoid non-local scope. So that means in your functions and methods, avoid accessing data that is not exclusively in the local scope of those functions and methods. More importantly than that, definitely avoid modifying anything that is not exclusively in the local scope of those functions and methods. And that's because, again, linking back to the principle of least knowledge, the further away you go from the local scope of something, the more dangerous it will be for you. It means the more knowledge you require to make sure that this thing over here isn't also used by these other three things, and if you modify it, you might break it. So that's the thing. If something is in the local scope of your functions, it's really easy to track because you can see the entire life cycle of every single variable in your function. But if something is outside of the local scope of your functions, then it's much harder to track. You don't know what its current value is, because if many things have access to that thing, they can change it. So that's the thing, code becomes more difficult to track and more difficult to understand and things like that. Now, that doesn't mean you always have to follow these rules and you never have to access anything outside of the local scope, but the further up you go from local scope, the harder it becomes to be certain of what certain variables are currently and what has happened to those variables over the lifetime of the program. So, how do you apply this particular point? So basically, instead of having a function where you access something that's out here, pass that thing as an argument to your function. So basically, anything that your function needs, pass it as an argument, and now it becomes part of the local scope. And of course, don't modify anything in your function that doesn't exist exclusively in the local scope of your function. So for example, if you created a variable inside your function, it's fine to modify it, as we saw for the last two slides. But if you passed in a variable that has an array outside your function, you passed it into your function, don't modify that, because that will be reflected up here as well. So as a quick code example, the function on the left here, double result, accesses and modifies a variable that exists outside of the local scope of that function. So that's basically what you don't want to do. And again, the reason why we saw in the principle of least knowledge. Something like this would be a disaster to work with because you don't know what result is when this function is called, unless you literally read through the entire lines of a file or a program, just so that you can know what result is at the current time when you call this function. The code on the right is much better because it doesn't access anything outside of its local scope and it doesn't modify anything outside of its local scope. So when you call function double with anything, you know exactly what it's going to do. You can predict the result properly. But on the function on the left, there is no way for you to know what it's going to do, again, unless you have a lot more knowledge about what has happened so far. And also, the variable initial value is constant, so you never have to worry about that. And the value of what result is again predictable. So the pointers so far have been about avoiding as many side effects as you can, at least immutability and avoiding non-local scope. But you can't always avoid side effects. As we said, sometimes you must modify the database, you must modify the DOM, you just have to have side effects. So in this case, all you can really do is just be extremely careful with the code that you write. As we've said already, side effects can be extremely tricky and extremely difficult to track. There isn't really getting away from any of that. You just have to be extremely careful and put in as much diligence as you can to this code, because if you don't, it's very easy to have bugs everywhere. So please invest the required time and effort required whenever you code something that has side effects. Another pointer for dealing with side effects is to separate your pure and impure functionality. And something that's pure is something that doesn't have a side effect, doesn't mutate anything, and doesn't access non-local scope on something mutable. So that stuff, your pure functionality, and your functionality with side effects, you generally want it separated. So for example, you don't want to have a function or a method that does both something like a calculation or an operation on an array or something like that, which would be something pure, and then also writes the results to the database or something, or to the DOM or anything like that. You want those two things separated. And this is basically the principle of separation of concerns, which we did a few videos ago. So if you understand that principle, hopefully you can see why you want things done like this. But for a quick explanation, it's because something like a pure function is generally easy to understand, easy to reuse, easy to test, and easy to change. And something like a side effect can be a lot more difficult with those things. So as we saw in separation of concerns, by changing those two, well, at least this pure part can be easy for you to work with, even if this side effect is difficult for you to work with. It's better than having them combined and now this whole thing is difficult for you to work with. Additionally, from a concerns point of view, something like a calculation is vastly different to something like updating the database. They change for vastly different reasons, and they're just completely different things from a code organization point of view. So, as that principle says, those should be separated. And just for a quick code example, here is some code that doesn't separate the pure and impure functionality. So this is technically the bad version of the code. Now, remember also that you need to be pragmatic. So if you had something like this in your code base, well, this is actually really, really simple code. So if you separated it, would you really gain much benefit? The benefit would be quite minor, But pretend, for the sake of example, that this is not simple code. Something in a real code base may be a lot more complicated than this. So pretend that the calculation or the operation that it's doing is much more complicated, and the side effect that it's doing could also be much more complicated. So in this case, you wouldn't want those two grouped together. This might be more appropriate. Again, if the code was more complicated, this might be how you would want to structure it instead. So you have a function called double array, which only does a calculation or an operation. So that's pure and that's good to go. Then you have the function display in DOM, and that's the function that has the side effect. So again, those two are separate, so they're easier to work with now. So the next pointer is, as much as you can, try to have clear areas of responsibility in your code. So again, this is kind of like separation of concerns for your code. For example, things like, if code A works on this part of the DOM, then ideally it should be the only code that works with this part of the DOM. Because if also code B and code C work with this part of the DOM, now you might have problems because code A may change something and break the other two, and so on with the other two. And also the code is harder to track and harder to understand and all those things. I believe it would be a lot easier for you to work with this code if code A works with this. And now if something happens to that part of the DOM, you know it's in code A. You don't have to worry about where the heck could it be. Because imagine if you don't have this kind of organization in your code, it might not just be code A, B, and C, it might be anything. So this kind of structure really helps. Another pointer regarding this is that I personally believe that something like the following structure is good. It goes like this. If code A needs this part of the DOM to run, then I believe that code A shouldn't even be called unless this part exists. So for example, you could use this code A perhaps in two particular ways. One way might be something like the following. Code A has an if statement in there asking, does this part of the DOM exist? And if it exists, then it does what it needs to do. Or alternatively, you could do it so that if this part of the DOM doesn't exist, code A is never called. So code A doesn't have a conditional statement checking if it should run. Code A is never called if its dependency doesn't exist. And at least in my personal opinion, this is my preferred way to do it. Now, this isn't a hard rule that you must always follow, but it is something for you to consider in your own code. Because what it means if you do code like this, it means that now code A is simpler than if it also had that conditional statement. And if your baseline units are simpler, well, I personally believe that makes code better and easier to work with. But other than that, another point on this slide is basically, if you have code that performs side effects, you just need to try your hardest to make sure that it doesn't conflict with other code that performs side effects. So that's not really something that can be explained very easily. It just says, try your hardest to organize your side effects effectively. So another point, which I think should be fairly easy for you to implement, is to handle side effects that come in pairs effectively. So consider the code on this slide. If you look at the code on the left, it opens a file, and then it has lots of different things in between, and who knows what it is in a real code base. And then it does something to the file, and then again, it may have a lot of different things in between. And then finally, after all of that, it closes the file. And now compare it to the code on the right. So on the code on the right, we have a function that opens a file, does something to the file, and it closes the file. And which one of these two seems the better option? So in my personal opinion, it's completely uncontested. The version on the right is significantly better. Because for starters, well, the code there is small, simple, and immediately understandable. But the code on the left, what the heck is that? Where is the organization there? You open a file somewhere, you do random stuff, you do stuff to the file, you may close it. If you don't forget, you may close it. And this is the important thing. So it's not just the organization here that's important, it's the side effects left open, and this could be a major source of bugs in your code base. So in general, it's nicer to write code like on the right, because you can never forget to close the file if it's closed in that simple function where it opened. So when you have side effects that come in pairs, I recommend that you do something like this. And we finally come to the last point, that is, consider using something like a framework or a functional programming language to delegate some side effects to. For example, if you're a front-end developer, and if you work with the DOM, then instead of you working with the DOM directly, you can use a library like React, or one of the many alternatives to React. Now, please understand that just because you're using React or another functional programming language, that doesn't mean that the side effects are not there. They don't disappear. All it means is that now you don't have to code them. The underlying framework or library or programming language handles them for you. But please understand that they are all still there. Things like functional programming don't remove side effects. They just help you organize them better, like we've been talking about in this video. But regardless of that, these can still be very good options. They might not be the right options for you, but they are definitely things to consider. Because back to React again, something like React basically allows you to write pure JavaScript, pure code, that produces an object of what the DOM should look like. So this is great because now you're writing in pure code. And remember, pure code is simple to understand, easy to reuse, easy to test, easy to change, all those good things. It's much easier to work with pure code than it is to work with code with side effects. So you generate that object of what the DOM should look like, and then React takes it, and React worries about doing the side effects. React worries about changing the DOM, and you don't. You just write your pure JavaScript and you're happy. As an extra bonus to something like this, something like React, and again, many other frameworks and libraries may do this, and programming languages can do this as well, but something like React helps you structure your code well. So as we said before in the point about clear areas of responsibility, with something like React, code A will not run if this part of the DOM will not exist. It's guaranteed to run only if the thing it needs on the DOM does exist. And this is great because, again, this is really good code organization that makes it easy for you to work. So again, before finishing this point, just a disclaimer, I'm not saying these as a recommendation to you. I'm just presenting them as options that you may want to look into and that may or may not be right for your project. So that's it. That was a really long video, but I hope that the concepts we talked about made sense and that they help you as you move forward in your career. So if you like this video, then please click that like button. And if you want to be notified of more videos that come out like this in the future, then please subscribe. It really helps the channel when you do those things. And finally, if you have any comments or even counter arguments or additional suggestions that we didn't cover in this video, then please leave a comment below. All right, thanks very much and see you on the next one.